Hi, it's Brandon with STEM Tutoring. In the last video, we talked about how algebra is just doing arithmetic backwards in order to find out what an unknown must be. And that unknown we represent as x in algebra. In this video, I want to focus on the most important three steps that you will need to solve 90% of problems that you'll come across in your algebra class. These steps will make more sense as we do some examples with them below, but first I'm just going to start by listing them out and trying to explain them. The first step here is to pretend that you're trying to solve the equation if you know what the unknown is. So if you know what x is, and then list out the order of operations that you would do in order to solve it, in order just to calculate what the expression on the left or right that contains x would have to be. The second step is to go through the list that you came up with in step one and to do the opposite of each operation on both sides of the equation, starting from the end of the list and then working backwards to the front of the list. And then step three is that after every operation from step two, you just check if x is by itself. If x is, then you're done. And then if not, you have to go back to step two. So even though these are just three steps, you're going to do step one time, step two, and then step three, you might have to do step two and three many times before you're finally finished. But they are the same steps repeated over and over. Now, one other thing before we get into some examples that I want to talk about is this idea of the opposite or the inverse operation that you do to both sides. This is a basic table showing some of the most common inverse operations. So here, if we have an equation that's x plus 3, then the opposite of that, or the inverse, would just be minus 3. If we have x multiplied by 3, represented here, then the opposite of multiplying by 3 would be division by 3. Those are pretty basic. But it can also get more complicated, and you can also extend this to more difficult functions than you would normally find in Algebra 1. So there's also an operation of squaring, which is basically multiplying x times x. The inverse of that is the square root. And then you can do the same thing with x cubed and the cube root, or x to the fourth and the fourth root. You can extend that indefinitely. As you get later into a pre-calculus class, what you'll probably come across is a function like this, which is called an exponential function. That's basically 3 raised to the power of x. And this inverse is a logarithm, so logarithm base 3. You don't really have to know what that means. I just want to emphasize that what we're learning here is used over and over and over again at higher level classes above algebra. And then here, this would be like a trigonometry function, cosine, and then it has an inverse that you can find on your calculator, the inverse cosine, and you can solve equations the same way as long as you are using the correct inverse function. So I understand things might not make sense, so I think the best thing to do is to jump into a couple examples. So the first example here is what we have as x plus 5 equals 7, and we're essentially solving for x. So step one, so I'm just going to do this as step one. Remember, step one is to list out the order of operations to basically solve for the left or right, assuming we knew what x was. So in this case, we're going to pretend that we know what x is, and then ask ourselves, what would we do after knowing what x is in order to calculate this left-hand side of the equation? Well, all we would have to do is add 5. So that's our list. Our list now for step one is just plus 5, add 5. Now going on to step two, we want to do the opposite of the last remaining operation from step one to both sides of the equation. Now this list really only has one element in the list. So if you have a list with only one element, then the last and the first are the same thing. So the last element here is plus 5. So what we need to do is we need to do the opposite of that, plus 5, which is subtracting 5 to both sides. So we'll do that here. So we subtract 5 to both sides of the equation, and then you see in step two, we should also cross out that operation from the list in step one. So we've done that, so we don't need to do it again. And then going on to step three, you can see that we actually would solve this. So x plus 5 minus 5 will equal 0, or x plus 0, which would just leave us with x. And then on the right-hand side, you can see that we'll have 7 minus 5, which just leaves us with 2. So now looking at step three, x is by itself, so we're done. If x was not by itself, we'd have to go on to basically repeat step 2 and 3 as many times as we would need to isolate x. But in this case, there's just one operation that we have to undo, and So we're done. And you can plug this back in to check. Obviously, it's about as simple as an algebraic equation could be, but 2 plus 5 does equal 7. So you can see how the steps here apply even to the simplest algebraic equation that you could think of. And now we're going to kind of build up from that and talk about some more complicated ones. So this one, now we're multiplying by 3 instead of instead of adding 3. So step 1 here, remember, that's we pretend that we know what x is, and then we come up with the list that we would have, or that we would need in order to calculate the left-hand side of this equation. So that would be basically multiply by 3, or times 3. And then step 2 basically says to do the opposite of that, starting at the last operation, do the opposite of that to both sides. So multiplying by 3 is the only operation in our list. We want to do the opposite of that, which is dividing by 3 to both sides. And then we can cross off that one in the list. And if we were to do that, you can see that we would end up with 3x divided by 3. That would just leave us with x, because the 3's basically cancel out. And then on the right, you'll have 6 divided by 3, which is 2. So again, the answer is 2. And then you check this. Obviously, x is by itself for step 3, so we're done. We don't have to do multiple versions of step 2 and 3. But if you plug x equals 2 back into the initial equation, you see that 3 times 2 does equal 6. And now let's get a little bit more complicated. So here, this time we're going to have 2 operations. So it's going to get a little bit more complicated, but you can see it's the same steps involved. So the first step is to list out, pretending we know what x is, how would we use the order of operations to calculate what's on the left. So the first thing that we would do, and this is where you have to think of PEMDAS, so PEMDAS for the order of operations, parentheses, exponents, multiplication, division, addition, subtraction. So here, we're multiplying by 3 and then subtracting by 4. And then according to PEMDAS, we know that we have to do the multiplication by 3 first. So multiply by 3 is our first operation, and then subtract by 4 is our second operation. So those are the only 2 operations. That's step 1. Step 2 is, remember, to do the opposite to both sides, starting at the end. So we start at the end of the list always, because algebra is about doing the opposite of arithmetic over and over in order to solve the equation, to get x by itself. So here we see the final operation is subtracting by 4. We want to do the opposite of that. Remember, that's adding by 4 to both sides. So we'll add 4 to both sides. It's basically what we need to do. And then in step 3, and also we should cross out that step. So we've already undone the subtraction by 4 with our addition by 4. And then you can see that in step 3, after we would actually do that, 3x minus 4 plus 4 will just leave us with 3x. And then 11 plus 4 should be 15. So now you can see that the equation is simpler, but we're still not done. So now in step 3, we would say, is x by itself? Then we're done. It's actually not in this case, because you can see we still have this multiplication by 3. So now we need to go back to step 2 basically and do that again. So let's do another iteration of step 2. And then here, and I can copy this down actually. So if I just copy this down, we would now pick the next operation off the end of the list that we created in step number 1 that has not been done yet. So we've already done the negative 4, and now we would need to do the multiply by 3 and take care of that. The opposite of that will be division by 3. So we have to divide by 3 on both sides. And then if we actually do that, if we actually find out what that would be, you can see that on the left-hand side, we'll just be left with x, and on the right-hand side, we'll be left with 15 divided by 3, which is 5. So 5 will be the answer here. All this is just repeating steps 2 and 3 over and over. That's all algebra is. The only trick is to get the order right in step 1, get the order of operations correct, and then in steps 2 and 3, you're just continually doing the inverses in the opposite direction. And if you continue that process, that's how you can reason backwards to find out what x has to be. So going on to another example that's a little bit more complicated. So this one might look a lot more complicated, but it uses the same steps. So the first step here is to just use the order of operations. So listing out what we would know based on if we knew what x was, how would we actually calculate the entire left side of this equation? And I'm just showing this example so that you can see that it works for even very complicated expressions or equations. The same steps still apply, even though you would probably never see something this complicated in an Algebra 1 class. So if you think of the order of operations here, the first thing that we would do is subtract 3. And the reason is because you can sort of think of it as parentheses. Even though the parentheses are not explicitly written around x minus 3, we have to do that before we divide by 2. So the first thing we would do here is subtract 3. Second thing we would do is divide by 2. The third thing that we would do is basically square the value that we have. So I'm just going to represent that with x squared. And then the final thing that we would do is basically take it to the second, or raise the base 2 to the power of whatever we got in the previous steps. So this is a much more complicated list than before. It's not just multiplication and addition anymore. It also has these more complicated steps of squaring and then raising a base to a power. But the same steps still apply. We're just going to be applying a lot more versions of them. So in the first one, what we're actually going to do, remember, let me quickly rewrite the equation that we're thinking about here. So this whole thing, actually let me rewrite that briefly. You can see that in step 2, the last operation on our list from step 1 is 2 to the x power. And you can see from our table over here, you can imagine that we basically have 2 to the x instead of 3 to the x. And you can see that the inverse of that, or the opposite, will be the logarithm. So what we want to do is basically take the logarithm, base 2, of both sides. So that's the inverse. And then we can sort of cross that off the list. After we do that, then what we'll end up with is this expression, x minus 3 divided by 2 squared equals log base 2 of 16. You can plug that into a calculator if you want, but for the sake of this video, I'm just going to say that it's 4, that's correct, but I'm not going to go into why it is necessarily. That's more complicated. But then we're just going to, so in step 3, we could tell that we're not done yet, so we need to do another version of step 2. So let's do that again. So now the next operation is squaring. So now we're going to need to take the square root of both sides, because that, you can see from this table here, the square root of x is the opposite of x squared, or the inverse. So we'll do that to both sides. And that's a common theme. You always need to do it to both sides in algebra. And if you do that, that would get rid of this, the square root would get rid of the squaring here, so we'll be left with just x minus 3 divided by 2. And then the square root of 4 is 2. And we got to make sure that we cross off that operation from our first list. Now you can see I could write step 3 again, but you can see that x is still not by itself, so we basically need to continue with this work. And then the next operation that we would do according to our list is division by 2. So now what we need to do is just do the opposite of that to both sides, which is multiply by 2. So if we multiply by 2 on both sides and cross off that operation, you can see that the multiplication and division by 2 here will cancel each other out, and then on the right-hand side, we'll be left with 4. So x minus 3 should equal 4. So that's our new simplified equation. And you can see we're still not done. We still have this subtraction by 3, so now we need to do the opposite of it one more time, using our last operation, which is subtraction by 3. Now we're going to add 3 to both sides. And you can see that we should end up with the final answer, x equals 7. And now for step 3, you can see that it really is by itself, so now we're finally done with this. And you can check this you can basically plug this in to verify this, but if you plug 7 into this equation, you'll see that it gives you the correct answer. It actually does give you 16 in a calculator if you plug it in. So this is way more complicated, but the point is, it's still the same 3 steps. You're just doing steps 2, and you're just basically repeating step 2 and 3 over and over. But it's the same steps. You can think about this a lot more systematically after you've seen this. So those are some main examples. And now I just want to kind of emphasize that these are the most important concepts in algebra by far. They're way more important than anything else that you learn in an algebra class, so it's worth spending a lot of time to make sure you really master them. Because if you can master these 3 steps, and particularly if you can remember the table of inverses, then you can solve 90% of algebra problems. But even after you solve them, there's still quite a few problems that you can't solve just with these techniques. You do need other techniques such as combining like terms, cross-multiplying, factoring, a bunch of other things for quadratic equations. So that's not enough. You are going to need to see more steps, so be sure to check in the video on the right here, and you can see some more in-depth steps for how to solve even more algebra problems that you'll come across. See you next time.